Question 81. The graph of f consists of a quarter circle here and two line segments. For x is between -2 and 4 inclusive. The question is to write the interval where f prime is negative. F prime is negative, then function f has to decrease, right? Because f prime is a slope of tangent line. That's a slope, right? So in this graph right here, function f decrease from here to here, right? So the x interval is from 0 to 2. So the answer has to be x is between 0 and 2, right? We should not include 0 or 2 because at 0 it is not differentiable, right? It is not, the f prime is not negative, right? At 2 it is not differentiable, so f prime doesn't exist. So x has to be between 0 and 2 exclusive. Question 82. What is the value of limit as x approaches 3 from right hand side f prime x minus 3? Right? Okay, as x approaches 3 from right hand side, then what about x minus 3? What we have to do is we subtract 3 here, 3 here. So x minus 3 approaches 0, right? 3 minus 3, 0 from right hand side, right? Let's say the value of x is 3.01 because x is approaching 3 from right hand side. Then 3.01 minus 3, that's a positive 0.01, right? So we know that x minus 3 approaches 0 from right hand side. Does that make sense? Then we have to find the limit. Limit of f prime x minus 3. Okay, remember f prime is the slope of tangent line to the graph of f, right? So as x minus 3 approaches 0 from right hand side, what about the slope? Look at this function right here. This is line, right? If it's a line, slope is always constant, right? What is this slope? Rise over run. Rise, -2, run, +1. Slope is -2, right? Slope of this line is -2, right? -2. So this f prime x minus 3 approaches to -2. That's our answer. Question 83. What is the value of limit as x approaches 0 from left hand side? 1 over f prime x. Okay, as x approaches 0 from left hand side, then what about f prime x? What happens to the slope? So as x approaches 0 from left hand side, look at this slope right here. At this point, slope is approximately +1, +1/2, 1/3, 1/10. It approaches 0, right? So slope approaches 0. Does that make sense? Then what about 1 over f prime x? 1 over f prime x. This value right here, the slope value right here, it is 0.1, 0.01. It approaches 0 from positive value. Remember, +1, +1/2, +1/3, +0.1, +0.01. Did I say that? So it approaches 0 from positive values, these values, right? Then what happens to 1 over f prime x? 1 over 0.1, that's 10, right? 1 over 0.01, that's 100. 1 over 0.001, that's 1,000, right? So as f prime approaches 0 from positive value, then 1 over f prime x approaches infinity. It increases without bound, right? So it approaches positive infinity. So this is the answer for this limit. Question 92. If the function f is differentiable for all x, which of the following is equal to f prime a? F prime a is the derivative of the function f of x at x equal to a, right? There are two definitions for f prime a. Number one is f prime a can be written with the limits as h approaches 0, f of a plus h, that's h, okay, h minus f of a over h. That's one definition. Number two, it can be written as limits as x approaches a, right? Here, f of x minus f of a, x minus a, right? So, f prime a can be written as this? No, right? No, and not h minus a. Here, b as x approaches 0. No, if it is x, x approaches a. Okay, so b is not true. C, limit as h approaches a. No, right? H has to approach 0. D, limit as x approaches a, f of x minus f of a over x minus a. So the answer has to be D. Question 94. If function f of x is equal to natural log x, which of the following is equal to f prime e? Remember the definition of the derivative. F prime a is equal to limits as h approaches 0, f of a plus h minus f of a over h, right? Here we're trying to find f prime e. So we're going to substitute e for a. E. Here our function f of x is equal to natural log x, right? So f of e is equal to natural log e. And f of e plus h is equal to natural log e plus h, right? So let's rewrite this definition right here. F prime e is equal to limit h approaches 0. We have natural log e plus h minus natural log e over h, right? This can be written as limit as h approaches 0, 1 over h times all of this expression right here, right? Using the log property, the property of logarithm, we know that natural log a plus b, natural log b, is equal to natural log a times b, right? What if we have a subtraction? Natural log a minus natural log b, that's going to be natural log a over b. Remember? Natural log a to the power of c, that is equal to c times natural log a, right? This c goes in front of log. Okay, so using these properties right here, we're going to use the second property actually. This expression right here can be written as natural log e plus h over e, right? If we have a subtraction, we'll have one natural log, and it's going to be a over b. Okay, just like this. So let's simplify this expression right here. E plus h over e. E plus h over e is equal to e over e plus h over e. So that's 1 plus h over e, right? So this expression can be written again as h approaches 0, 1 over h times natural log 1 plus h over e. So the answer is B, right? So the answer is B. Question 96. Find the value of this limit using the definition of the derivative. Okay, we know that the definition of the derivative of the function f at x equal a is equal to f prime a is equal to limit h approaches 0 f of a plus h minus f of a over h, right? So we're going to compare this limit with this limit right here. First, this expression right here has to be equal to this expression, right? And this expression must be equal to this expression, right? So f of a plus h must be equal to 5 times negative 1 over 2 plus h to the power of 4. And by looking at this input right here, negative 1 over 2 plus h, we know that a must be equal to negative 1 over 2. So this a is negative 1 over 2. Then what is our function f of x? F of x is equal to, well, instead of this expression right here, I substituted x for this, okay? So x for this. So that's going to be equal to 5 times x to the power of 4, right? What about this expression right here? Negative 5 over 16. Well, 5 over 16 has to be f of a, right? And we know that a is negative 1 over 2. So f of negative 1 over 2 must be equal to 5 over 16. Since f of x is equal to 5 times x to the 4, f of negative 1/2 is equal to 5 times negative 1 over 2 to the power of 4. So that is equal to 5 times 1 over 16. So that's 5 over 16, right? So we just check that f of a, which is equal to f of negative 1 over 2, is equal to 5 over 16, right? Here, since a is negative 1/2, all of this expression right here, all of this limit value is equal to f prime, well, if the function is f prime negative 1 over 2, right? So we have to find the value of this limit right here. Then that is equal to f prime negative 1 over 2. And we know that f of x is equal to 5 times x to the power of 4, right? So let's find f prime negative 1 over 2. F prime of x is equal to, using the power rule, 5 times 4, 20 x cubed, right? So what is f prime negative 1 over 2? That's 20 times negative 1 over 2 cubed. So 20 times, so that is equal to 20 times negative 1 over 8. So that is equal to 4 times 5, 4 times 2, negative 5 over 2. Negative 5 over 2. That's our answer. Question 100. Which of the following must be true about limit of this expression, this function? Okay, limit as h approaches 0 and we have h in our denominator. This expression comes from the derivative of the function, right? So the definition of the derivative of f at x equal a, which can be written as f prime a, is equal to limit as h approaches 0 f a plus h minus f of a over h, right? So this expression right here, sine 2 pi over 4 plus h, that has to be f a plus h, right? So f of a plus h is equal to sine 2 times pi over 4 plus h, right? So a plus h, pi over 4 plus h. This means a has to be pi over 4, right? So f of x is then equal to sine 2x, right? Instead of this expression, I have x, pi over 4 plus h. Instead of a pi over 4 plus h here, I have x, right? Instead of this expression, I substituted x. Does that make sense? So function is equal to sine 2x. Sine 2x. And this, we have to check. This expression right here is equal to this expression. F of a, well, a is actually pi over 4, right? So f of a is equal to f of a pi over 4. That is equal to, if the function f of x is equal to this, that's sine 2 times pi over 4, which is equal to sine pi over 2. So sine pi over 2, that's 1, right? So we have 1 here. Does that make sense? So function f of x is equal to sine 2x. Okay, so far so good. All of this expression is equal to f prime a, or in this case f prime pi over 4, right? So all of this value is equal to f prime pi over 4, right? So when we look at answer choices, f prime, all of this limit value is equal to f prime pi over 4, where f of x is equal to sine 2x. So the answer has to be B. Question 102. If f is a function such that limit is equal to, which of the following statement is true? This limit expression actually comes from the definition of the derivative, right? F prime a can be written as limit as x approaches a, f of x minus f of a over x minus a, right? If we look at limit right here, x approaches a. If x approaches a, we have a here, we have a here, right? So as x approaches negative 4, we have a negative 4 here, and this expression right here, that's actually x minus negative 4, right? So we know that a is equal to negative 4. So all of this expression right here, all of this expression represents the derivative of f at x equal negative 4, right? Which we can write as f prime negative 4. So f prime negative 4, that is equal to 2, right? Does that make sense? So slope of tangent line of f at x equal negative 4 is equal to. Now let's look at answer choices. A, f of negative 4 is equal to. We know that slope is equal to 2, not the function value, right? We don't know if the function value at x equal negative 4 is equal to 2. So that's not true. Answer choice B. The derivative of f at x equal 4 is equal to 2. That's not true, right? The derivative of f at x equal negative 4. This is negative 4. So this must be negative 4, right? At x equal negative 4 is equal to 2. So that's not true. Answer choice C. F is continuous at x equal negative 4. That's true, right? Because the derivative of f at x equal negative 4 is equal to 2, which means it is differentiable at x equal negative 4. If the function is differentiable at x equal a, then the function has to be continuous at x equal a, right? So we know that f is continuous at x equal negative 4. So that's the answer. That's true. Okay, the answer choice D. It says the derivative of f at x equal negative 4 is continuous. We know that f prime negative 4 is equal to 2, but we don't know that if f prime, the derivative of f, is continuous at x equal 4. X equal negative 4, right? So this is not always true. The answer for this question has to be C.